Hi, my name is Tom Cashman, VP of Engineering at GPR, and I'm here to tell you a little bit about our novel technology that uses ground penetrating radar for vehicle navigation and particularly vehicle positioning. So we like to say that we're unearthing the future of autonomy. And we do have an MIT connection. Our co-founder, Byron Stanley, developed the start of the technology at MIT Lincoln Lab. Really, I'd like to start with autonomy, localization, and the problem that we're trying to solve today. So a lot of autonomous solutions use camera and LiDAR to localize a vehicle, but this can have some shortcomings. So traditional sensors, they could be obscured by things like rain or snow if you're looking at lane lines or using LiDAR to really localize a vehicle off semantics, being above ground features, let's call them. And then if you don't have landmarks or don't have lane lines, you could have scarcity where you don't have anything to localize and you can't really navigate the vehicle. Tunnels and parking garages would be obstacles if you're using GPS. So all the different modalities that we have today have some issues presently. And GPR, we offer a highly available positioning solution that eliminates some of these challenges. And I'll talk to you about that in subsequent slides. How does GPR work and how do we really address these shortcomings? So as opposed to looking above the ground using visual cues, we look under the surface. We do this by scanning the subsurface to create a 3D map. It's a 2D slices of the subsurface concatenated into this three-dimensional map that the vehicle drives along the route. On subsequent traversals of this route, we again scan these 2D sections and we run pattern matching algorithms very, very quickly to localize a vehicle with 5 to 10 centimeter precision. In other applications, we can get even more precise. Now, it's instructive to know that this solution isn't really impacted by rain or snow or any of the other shortcomings from those other modalities mentioned before. We do this by mounting a ground penetrating radar that has a really nice, thin, elegant profile underneath the vehicle. It uses electromagnetic waves that we transmit into the subsurface and receive reflections back to create this digital signature or this footprint of the subsurface, which again, we use to compare map scans to localization scans. There's enough character in these scans to create a unique position and a unique fingerprint throughout all different environments. Now, we do use some proprietary signal processing techniques to filter out some of the commonality within the subsurface to extract surface anomalies or subsurface anomalies that create this fingerprint. Our use case or customer story. So we are working with this company called BTG in the Netherlands. So we do have a global solution and we're really targeting the seaport industry where they're moving shipping containers in an autonomous fashion. We have signed a deal. The value of the deal is roughly $40 million, and we're unlocking a solution for BTG to navigate throughout the seaport in both trains and AGVs. Other industries. So this technology can be deployed in a multitude of applications, whether it's automotive or mining and quarry, to last mile delivery or even indoor manufacturing. So solving the problem where you don't have GPS and other modalities don't work, we can adjust this and apply the solution to all of these different applications. And ultimately, we're looking for pilots, customers, and even partnerships. So any of these things that are of interest to GPR as well. Any questions?
Yeah, so please post your questions to the Q&A tab. I'll start with one about the sensors. So when does it not work, let's say?
It's a fantastic question. So since it's a ground penetrating radar technology, if you are driving over a lengthy metal surface, then the reflections can't penetrate the surface, and therefore we can't localize the vehicle in that case. We would use dead reckoning or some other modality to traverse what we find is typically a very small stretch of land.
Okay. And what about any regulatory approvals? Are those necessary at any step?
They are. Since we're emitting electromagnetic waves, we fall within the FCC or the EU or other governing bodies that regulate emissions. Now, we do have FCC approval, And we have a line of sight, and we're getting EU approval, followed by Canada, Japan, and China, as well as approval in South America.